Hello and welcome to this section 2.1 lecture today for Algebra 1 Part 2. Today I'm going to try to go through some of this relatively quickly in an effort to give you, keep it short and so that I can get it up, get it online a little bit quicker. We have some definitions. I have them typed out already. So if you need to pause the video while I talk about them, feel free to do so. I tried to make the video once and my pen started lagging out, so I didn't want to rewrite them and try to write them quickly. It just makes it ugly. So the first one is a ratio. It's a comparison of two quantities. Actually, let me take that back. Yeah, with the same units. Sorry. And this is often, I'm not going to say overlooked, but a ratio should have two things with the same units, whereas a rate is going to be a comparison of two quantities with different units. They're often talked about at the same time, and at the end of the day, who really cares what you call what? And that's what it kind of comes down to. There's even going to be times that I say to write a ratio, and it's actually a rate. And sometimes it just depends on how you look at it, okay? So again, a rate is a comparison of two quantities with different units. A unit rate is a rate where the denominator value is equal to 1. That's the unit part of it. And we're going to look at that. Most common one that you probably deal with, or at least hear about on a daily basis, would be like miles per hour. That's a pretty common one. So that's the number of miles that you would travel in 1 hour, is what that's meant to say. Lastly, a proportion is an equation that involves two ratios or rates, however you want to look at it. So that's what a proportion is. Let's go ahead and get started here. I consider these to be ratios because I'm looking at ducks and geese, looking at birds at Mingus Park. Okay. So one day, Mr. Gall went to Mingus Park, and let me back up, I guess. I could see where you might consider them rates, as they're not ducks and ducks or geese and geese. And so again, at the end of the day, it doesn't really matter. There are multiple ways that we write ratios. There's definitely one that we're going to prefer, but I do want to show you all of them just so you're aware that they can be possibilities that we will see. So it says write the ratio of geese to ducks. Okay, there's 9 geese and 16 ducks, so we would say 9 to 16. Okay, if somebody were to ask the ratio of geese to ducks. Okay. And another way, more commonly for math classes, we would see it written as a fraction. But there are times that you'll see it with just a colon in the middle, okay, the two vertical dots. Just saying that you're comparing this number to this number. Okay? Like a lot of times like in a scaled type of ratio. Now write the ratio of ducks to all ducks and geese. Okay? Ducks, there's 16 of those. And then ducks and geese together, there's 16 plus 9, which is 25. Okay? And again, more commonly, we would probably write that as 16 over 25. Next one says, my bathroom has a tiled floor with 2 different colored tiles, blue and white. There are 72 blue tiles and 144 white tiles. Write the ratio of blue tiles to white tiles. Blue, there's 72. White, there's 144. So we might say 72 over 144. And I guess I should have backed up and said this earlier, but it wasn't a factor earlier. When you're unsure, it is okay to reduce ratios. Okay, at least most of the time. If they ask that they just want to know the true ratio, then I would leave it as it is. But in a situation like this, the numbers are so big, it might be nice to know that for every 1 blue tile, there's 2 white tiles, because this does reduce to 1/2. They're both multiples of 72. Next one, write the ratio of white tiles to all tiles. White tiles, there's 144. All tiles, there's 72 plus 144, which is going to be, what are we thinking here? 216. And reducing wise, I know that they're both multiples of 9. Hold on a second. 16, I'm guessing 16 over 24. So it turns out that they're both multiples of a bigger number, probably 12. Yeah, that makes sense. But if I divide them both by 9, sorry, again, I'm trying to go fast here and at least get it done. Those are both multiples of 8, so that's going to be 2 to 3. Okay, so I would say that there's 2 white tiles to every 3 total tiles. And that you probably could have found out from there. But that's okay. All right, let's move on. For unit rates, okay, unit rates, again, we want to find the ratio, or find the rate. So we want to find the rate, whatever it is as it's given, and then here we're going to kind of be okay. Usually we don't like to mix decimals and fractions, but here we're actually going to do that. Okay, we're going to divide the values and write it as a fraction. Okay, and we'll look at a couple examples to see what I mean by that. So looking here, it says the trip from North Bend to Eugene is 113 miles. Mr. Gall drove there in his Toyota Tacoma, and he used a total of 5.24 gallons of gasoline to get there. Find the unit rate in miles per gallon. Okay, so this tells me the way that I want to do it. This part of the question tells me what rate I'm looking for. I'm looking for miles compared to gallons. So 113 miles took 5.24 gallons. And I want to find this fraction with 1 in the denominator. That means I actually want to do the division. So I want to look at 113 divided by 5.24. And that tells me 21.56 is good enough. 21.56 miles over 1 gallon. That's what actually dividing that tells me. Okay, I'm dividing both the top and bottom by 5.24. When I do that on the bottom, I get 1. When I do that on the top, I get 21.56. And we would more frequently write this as 21.56 miles per gallon. Next one says, suppose Mr. Gall made the same trip with the freshman football team in a white minibus, one of our activity buses. The minibus used a total of 8.13 gallons. So we're going to do the same thing. 113 divided by 8.13. Pull my calculator back out. Do the division. And I think we're good with saying 13.9. So 13.9 miles per gallon. And you could have written it the same way here and then answered with the final answer like I did. But I just skipped that step. So obviously my Tacoma gets a little better gas mileage than one of the white minibuses. Solving proportions. Okay, when we're solving proportions, we want to solve for the variable. And I think this is funny that later on in more formalized testing, you might run into situations like this where they're actually asking you things like these with words. They're called analogies. Okay, and especially written this way on these first three. 22 is to 6 as x is equal to, as x is to 15. So 22 is compared to 6 as x is to 15. Now, the tricky part about this, I guess, it's not really a trick, but in order to solve this, you've probably talked about other ways. But when the variable's on top, if I were to just multiply both sides by 15 here, I think I would get the variable by itself. Those 15s cancel like we talked about last week, and we would end up with an answer. So here I might go 22 divided by 6 and multiply that by 15. And I get 55. So x is equal to 55. The next one, 9 is to 2, as m is to 12. So I just want to solve for m. I'll do that by multiplying by 12 on both sides. 12 times 9 divided by 2, 54. And the last one of these, 2 is to 5, as x is to 3. Or as what is to 3 is how an analogy would ask that. This one's probably not going to be too nice, just looking at it. 3 times 2 is 6, and 6 divided by 5 is actually going to give us x is equal to 1.2. 6/5 is 1 1/1/5, which is 1.2. Okay, these next ones are a little bit more involved because there's a little more happening in each one of these equations. I am sorry that they are so small. I think it thought I was writing in a different way, but oh well, we can deal with that. Yeah, these ones are a little bit more involved, but we still treat them like we're solving equations. I want to multiply by 39 first to get that denominator out of there. And I'm going to use my calculator for that. 39 times 5 divided by 13. Oh, 15. That's kind of nice. I get 15. Those 39s cancel, and I get k minus 4. Add 4 to both sides, and we'll be good to go. Should get that k is equal to 19. Okay. Next one we have here. This one's a little tricky. I guess I would do it this way, but I would argue that there's an easier way to do this. I'm going to multiply both sides by 5 to get that 5 out of the denominator, since it's attached to that variable r. And I'm going to have 3r is equal to, I'll talk about why I'm laughing about it in just a second. 36 times 5 divided by 15 gives me 12. And then I would divide both sides by 3. So r is equal to 4. The reason I find this one actually a little bit funny is that 3r over 5 is the same thing as 3/5 r. And we would actually solve that equation a little bit differently if we use our techniques from last week. I would actually multiply both sides by 5/3. And I argue that that would be a lot easier because there would be some cross-reducing I could do. A lot of stuff would be a lot easier if I were to look at it that way. But if not, go at it this way, multiply the 5, then divide the 3. Sadly, there's not that kind of a trick on ones like this last one. This one's kind of like the first one that we started with. I don't have any quick trick to deal with the -3 in the numerator, so I have to multiply both sides by 8. 8 times 7 is 56 over 112. And then c minus 3 is what I'm left with. I guess the only trick here is that 56 over 112, and if I would have done that on a calculator, I would have got the same thing. 56 over 112 is 1/2, right? So I get 0.5 there. So if I want to think of that as 0.5 or 1/2, I'm not really picky. I know we could kind of argue that this problem started with fractions, but I'm okay with this too. So we'll add 3 to both sides, and we get c is equal to 3.5. And I am okay with that decimal answer on that one. Proportions are always kind of weird, right? They always kind of break some of the normal rules that I follow. So that being said, make sure that you write any questions you have over on the left side of that line and ask them when you come to class. So we'll start class with that, and then we'll get into the examples. The examples won't take very long. Okay, it'll be a lot of writing ratios and rates and unit rates, and then a couple solving proportions. So hopefully that helped. Have a good day, and we will see you in class.